This is Physics 2212 Lab 1 Charged Tapes. For this experiment, we will observe charged pieces of clear tapes and do an experiment to determine approximately how much excess charge is on one piece of charged clear tapes. We will explore the physical property of the charge. We will observe how charge affects object behavior. The fundamental physical principle we use in this experiment is Coulomb's law. We use equations to calculate electric fields and electric forces. The result of this experiment is that the clear tape has a charge of negative 1.2 times 10 to the power of negative 8 coulombs, which means an excess of electrons. The procedure of this experiment is first to create two upper tapes by quickly pulling them up enough the base tapes stuck to the desk. And then you need to rub a clear plastic ruler with your hair and observe the repulsion between it with the upper tapes to check if the upper tapes contain negative charges. You need to lift one upper tape under the other until the top tape floats. Lastly, measure the distance between the two tapes. We assume the tape at the bottom is tape A and the tape at the top is tape B. Since the momentum of tape B is not changing, the net Y component of the force on tape B is 0. The electric force due to tape A exerts mainly vertical forces on the floating portion of tape B, which counteracts tape B's gravity. And for the first model of this experiment, we assume that each upper tape has the same net charge, and we treat each tape as if all its charges were located at a single point at the center of the tape. We measured the tape length as 0.223 meters. The tape width is 0.0214 meters. The tape mass is 0.0002 kilograms, and the distance between two tapes is approximately 0.024 meters. We derived the values for the gravity force on tape using the tape mass. The surface area is equal to the tape length times the tape width, and we use the surface area divided by the atom area to calculate for the number of atoms. And for the calculations, we assume the electric force is equal to the gravity force, and we use the Coulomb's law to calculate the tape charge. Then we use the tape charge calculated and the electric charge to calculate the total excess electrons. And lastly, we use the total excess electrons calculated and the number of atoms to calculate the ratio of excess electrons to atoms. So for the first model, we model the charges on each tape as a single point charge located in the center of the tape. We first list out all the physical constants we need, and then for the calculation part, we wrote down the equations mentioned in the previous slides. Then we visualized the 3D model in glow script after running the code, and we got the results, which are exactly the same as mentioned before. For the second model, we modeled the tapes as lines of charges. For the physical constants, we update the mass of one tape as 0.0002 kilograms. We use the data from the first model to estimate the net charge on one tape, which is 1.12 times 10 to the power of negative 8 coulombs. And then we use the Coulomb's law to create a function for the electric field. We update the Y components of the start position attributes to represent correctly the vertical locations of the tapes. In the for loop, we update the equation to calculate the electrical force on the top tape due to the bottom tape, and then we create the arrow for the net electric field at the top tape due to the bottom tape. Then we visualize the 3D model in the glow script after running the code. We got the magnitude of the electrical force, which is 2.98 times 10 to the power of negative 4. And we got the magnitude of the gravity force, which is 1.9 times 10 to the power of negative 3. For the reflection questions, the first one is that what if the signs of the electrons and the protons were reversed? So if the signs of the charges were reversed, the electric field and the electric force would change direction, but each tape would still have the same charge and would still repel. The second question is that the two computational values for Q will be different. Why are they different? Which value is more likely to be closer to the real value? So the first model charge was 1.12 times 10 to the power of negative 8 coulombs, much larger compared to the line charge model, which was 4.37 times 10 to the power of negative 9 coulombs. This may be because the first model assumes all the charges are concentrated at a single point, making the electric field and force larger. Therefore, the line charge model is more accurate.